Share the screen. So first we'll discuss what we have done yesterday. So it's very important to discuss that also.
Mhm.
Okay. So yesterday what we have seen was all about the normal distribution. Yes or no, Zaid?
Yes,
All about
yes.
distribution, how the curves of normal distribution it is. Okay. The
Mhm.
curve of a normal distribution is symmetric. Okay. It is a single peak
Mhm.
having a mode in it, and it is defined by two parameters. One is the mu, which is known as the population mean, and the other is the sigma, that's known as, which measures the variability in the data, which measures that how much a single data point is far away from the mean. Yes or no? So that was sigma,
Yes.
that's also called as population. When we write sigma, it's population standard deviation, and when we write sigma square, it's variance. Okay. So now today in the topic, the main thing that we will discuss is all about the thing that what we have learned in the density curve. I'll just revise it in the density curve. Yesterday, I also have told you that in the density curve, we have seen that, for suppose this is the x-axis and my
Mhm.
density curve line is this. So there is a specific height there. For suppose the height is 1 by 2. And for a region, what we have to calculate the area under the region. So we take the values on the base, on the x-axis as the base, yes or no, and as the base. And when we need to find the area, then what do we do? When we need to find the area, we just multiply height by base. Here, in this
Mhm.
case, in the density curve, the figure that it had a straight line. Straight line. The density curve generally represents a straight line. But here in
Yeah.
the normal distribution curve, straight line is not there. Yes or no? There is a bell curve. So
Yeah, there's
can
no
what
straight line.
specific region, if I'm telling you that calculate the area of this specific region, or tell me what area lies in this region, this curve. So it is not possible. It is it is not possible by multiplying the height by multiplying the height multiplying the base and height and finding the area. Why it is not possible? Because the height, because I write it here, because the height of the curve is not constant, not is not constant,
Mhm.
is not constant. And also we cannot determine the height. We cannot determine the height as it is changing continuously. We cannot determine as it is changing continuously, as it is changing continuously. Yes or no? We have seen there is a continuous change in the height. The height is not constant here. If we see this part also, for which we have to calculate the area, the height of this distribution is changing continuously. So it is impossible for using the rule for calculating this. So now the picture of standardization, the picture for calculating, calculating the area under a normal curve, under a normal curve, normal curve, we use Z score. Curve, we use Z score. Z score or Z score as you. say, as you pronounce it by your efficiency, z-score. So what we need to do, we'll look in today's class. Okay, so we'll see it here. Okay, think z-score is somewhere upside. Here, I think it's here. Okay, so there was a question here. As we were finding the area, for suppose I'll take this graph here. Okay. Now seeing the curve, the question is here that we have to find the area under this curve. Is the question visible, Zaid? Yes or no?
Yeah, I
So
see the question. Yeah.
yeah, so we have to find the area here. So now how we'll find the area? Okay, we don't have a
By
specific height.
doing
So now what we'll do, we need to find the area of 6 here, where 6 is
so
here.
it's minus 6.84 divided by the
Correct.
standard
Now,
deviation of, I don't know, maybe like
correct. So
one
we need to
point.
calculate the z-score of 6. So z-score will be the value minus the mean. So what's the mean of the data? Is it given there? I think 6.84 upon 1.55.
Mm-hmm.
6.84 upon 1.55. So the calculation came out to be minus 0.54. Yes or no? Minus is
Mm-hmm.
also correct. Minus is also correct. Why? Because it is on to the left hand side of the mean. Yes or no, Zaid?
Yes,
Yes. So
exactly.
left hand side of the mean. So that's the thing. So we have obtained a z-score of minus 0.54. Now, what thing is there for the z-score? How do z-score determine the area? So it's very simple that there is a table. See, we have brought this value 6. We have brought this value to a standard normal score. Standard normal score. Standard standardized score. Standardized. This is also known as standardized score. So what's the standardized score of 6? So I'll say minus 0.54 for this data set. Yes or no? So I'll look this minus 0.54 in the Z table. There is a Z table. So I'll search for this minus 0.54 value. So what I'll do, not referring to the books Z table, we'll open our Z table. Okay. Okay.
Mm-hmm.
Z table. Uh,
The
and
Z table, okay.
Yes, Z table. And we'll open a negative Z table, negative side, where negative side also appears. So, because we have to search minus 0 point. Yes,
Mm-hmm. Yes.
Z table, that's okay. What I'll do, I'll do? Print screen, pick it up from here. Okay, okay. So it's not clearly visible. I think I shall take the downloaded version of it. I'll take it, actually. Wait a minute. I'll download it.
Mm-hmm.
I'll download it.
Okay.
Yes. Okay. So now I'll check this table because it will be more clear for you for referring the board afterwards. That's the reason I've downloaded
Yeah.
it. Okay, I'll take till year only. Minus 0.54 we have now. Okay. So moving on to the thing, control tab here. Okay. Now control V for pasting the table. Yeah. So I've
Mm-hmm.
pasted the table here. Now what this is the Z table, which there are multiple Z scores in it. Okay. So we have to search
Yeah.
for minus 0.54. So how do we search? See here, minus
Mm-hmm.
minus 0.54. So the first two digit, the digit before the point and the digit after the point, these first two digit, we will search into this column, into this. vertical column. I'll be more clear. Into this column, into this column. So where is minus 0.5? It's here. Yes or no, Zaid?
There. Yeah.
And second digit is, it can be zero also. So if it is zero, we need to search it in this horizontal. The
It's
second,
negative 29460.
yes, so it will be minus 0.54. So it will be 0.54. It will be 0.54. So it will be 0.29460. Yes or no? So I can write this as
Mm-hmm.
0.2946. So this data is under point. So we need to write how much like this. How do we convert this into percentage? It is 29.46%. So how much data
Yeah.
is below 6? So if we refer to the density curve here, we have find the area, we have find the percentile. So how much data is there? 29.46. 29.46% of data is below the 6 value. Yes or no?
Mm-hmm.
So how much data is there? 29.46 percentile of data. Percentile of data is below 6. Is below 6.
Yeah.
And remember one thing, whenever we calculate the area, we always calculate whenever we calculate the area, whenever we calculate the area in a curve, area in a curve, we generally, we generally do it, do it for the lesser side, for the lesser side. For
That's
example,
the side.
lesser side. What does it mean? So if there is a probability curve, okay? So likewise in
Mm-hmm.
this example, we had drawn a line, okay? And we need to find the area which is lesser than 6. Yes or no? Lesser than 6.
Yes.
If there was a question that if we had to find the area which is greater than 6, so the Z score does not give us the score for greater than. Remember this. If we calculate the Z score of 6 and we look into the table, it does not give us the value which is greater than. The percentage of the
Mm-hmm.
data which is greater than 6. It always gives us the value which is less than. Means it will give us the value about this region. It will give us the value about this region. So how we will find the area of this region? So you know the total area, the total area, the of the total area of the normal curve. Means I'm talking about the area of the whole curve, whole normal curve. The
Mm-hmm.
total area of the whole normal
One
curve,
number.
whole normal curve is always one. Is always
One.
one. Okay. So what I'll do, I know that this area is 0.2946.